is Algebra 1, Lesson 54. We're going to be talking about the substitution axiom and simultaneous equations. An axiom is a rule, and the substitution axiom says that if two expressions, A and B, are of equal value, then A may replace B, or B may replace A, number one, without changing the value of the expression. If A equals 2, if A equals B and A equals 2, then B equals 2. The value of the expression does not change. Number two, A may replace B or B may replace A without changing the truth or falsity of the equation. So if A plus 2 equals 3, then B plus 2 also equals 3. And if this equation was true to start with, it's still true. And if it was false to start with, then it's still false. 3. A may replace B or B may replace A without changing the solution set of the equation. So of all the possible answers, if A plus 3 equals Q, those are still the possible answers if B plus 3 equals Q, if A equals B. Okay, so here's a simple substitution problem. We've done these before. Here's x squared times y over p. If when x equals 2, y equals 4, and p equals -1. So we just substitute those values in, and we have 2 squared times 4 over -1. Which equals 4 times 4 over -1, which equals -16. Okay, now let's do some more challenging ones. If we have bigger problems with more variables, one of the ways we can find solutions are with simultaneous equations. So we have 2x minus y equals 1, and x equals -3 plus 11. We already know how to find an ordered pair for each equation, so let's do that. We're going to have to solve this one for y. We move this over here, that'll be 2x minus 1. We move this over here and this over here. And then we can pick a convenient number for x to put in here. So, for example, if I choose 3, then y equals 2 times 3 minus 1, and y will equal 5. So our ordered pair would be 3 and 5. Okay? Let's find an ordered pair for this problem. So we're going to move the 3y off by itself and the x over here. So we'll have 3y equals minus x plus 11. And then we multiply both sides by 3. And y equals -1/3 x plus 11/3. Okay, find a convenient value for x. How about 3? And then we substitute it in. And y will equal, this cancels, we have -1 plus 11/3. This would be 3/3, so this would be 8/3. Okay, so this ordered pair would be 3 and 8/3. Or you could do 3 and 2 2/3. But neither of these ordered pairs is a solution to both of the equations. If we need one solution that will satisfy 2 or more equations, we call the equations a system of simultaneous equations. The reason we would want to find one solution to 2 equations is to find where their graphs cross. So an ordered pair that fits both equations, if we graph the equations, that would be where their graphs, if we drew their graphs, would cross. Okay, so We find a simultaneous equations by setting them up like this. Here's 2x minus y equals 1. X equals negative 3 plus 11. We put a brace in front of them to show that we're going to solve them simultaneously. And what we're going to look for is an ordered pair shared by both equations. If there isn't a common ordered pair, we will end up with a false statement like 1 equals 3. And in that case, the graphs will never meet. Okay, so we are going to start by looking for something to substitute. We have x equals negative 3y plus 11. So we can substitute the negative 3y plus 11 into the x in the other equation and then solve for y. So let's start with that. We have 2x minus y equals 1, and we're going to substitute this for the x. So that will be 2 times negative y plus 11 minus y equals 1. This is negative 6y plus 22 minus y equals 1. Put the y's together and then get the 22 on the other side. So we have negative 7y equals negative 21. Divide both sides by negative 7. And we have y equals 3. Okay, now we know that y equals 3. We can substitute this value of y back into the other equation. So we have x equals negative 3 times 3 plus 11. X equals negative 9 plus 11. So x equals 2. So that's your ordered pair for both equations, 2 and 3. Then we are not done yet though, because you are eventually going to find problems where the ordered pair you find do not actually work in both equations. So the next thing you always need to do is check. So we're going to substitute both of these values back into these equations and make sure that they come out as true statements. So starting with this one, we'll have 2 times 2, this is 2x minus y equals 1. So 2 times 2 minus 3 equals 1. 4 minus 3 equals 1, so that is true. Okay, the next one is x equals negative 3y plus 11. If x equals 2, then this is negative 3 times 3 plus 11. 2 equals negative 9 plus 11, and that's true. So this ordered pair does indeed satisfy both of these equations, and if we graph the equations, this is where the graphs would cross. Okay, let's try another one. We have 2x plus 3y equals negative 13, and y equals x minus 6. Since we already have a y equals, we're going to substitute that into the first statement. So we have 2x plus 3y equals negative 13. We're going to substitute this x minus 6 into this y. 2x plus 3 times x minus 6 equals negative 13. Pull this out. 2x plus 3x minus 18 equals negative 13. 5x minus 18 equals negative 13. Add both sides by 18 and cancel this guy out. So we have 5x equals 5 and x equals 1. Now we're going to take this one and substitute it back into the other equation. So y equals 1 minus 6. And therefore y equals negative 5. So your ordered pair is 1 and negative 5, and now we need to check. So we're going to do 2 times 1 plus 3 times negative 5 equals negative 13. 2 plus, that'll be minus 15 equals negative 13, and that's true. Okay, let's check the other one. Y is negative 5 equals 1 minus 6. Negative 5 equals negative 5. So that's true. So this is a correct ordered pair for both statements. Let's try another one. 3x plus 2y equals 3, and x equals 3y minus 10. So we can use this x and substitute into this problem. So we'll have 3 times, and this is our x that we're substituting, 3y minus 10 plus 2y equals 3. So we have 9y minus 30 plus 2y equals 3. Add 30 to both sides. And add the y's together. And we have 11y equals 33. So y equals, divide both sides by 11, and y equals 3. Now we can substitute this back into the other problem. We have x equals 3 times 3 minus 10. So x equals 9 minus 10. So x equals negative 1. So our ordered pair is negative 1 and 3. And now we get to check. So here's our first one. 3 times negative 1 plus 2 times 3 equals 3. So we have negative 3 plus 6 equals 3. And that's true. And this one is going to be negative 1 equals 3 times 3 minus 10. Negative 1 equals 9 minus 10 is negative 1. So that's true. Okay, that's all. Let me know if you have any questions. Thanks.